Assalamu alaikum everyone. In this session, we are going to talk about two things: how much to produce and how much can be produced. This is also the reference to our ongoing case in point, that is the Domesco washing machines and dryers, where they were facing this problem that despite their increase in sale, they were having rising costs, the variable costs, and as a result, their profit margin was declining actually, and it was going into negative. So here, when we talk about how much to produce, and we try to equate it with how much can be produced, we look at capacity constraints, break even, and bottleneck related issues. Managers, when they talk about resources, they consider equipment selection and capacity decisions. They tie it in with their overall mission and strategy. In doing so, they have four considerations, important ones to make. The first one is accurately forecasting demand. We have talked about it earlier on. The second one is understanding the equipment, processes, and capacity increments. The third one is finding the optimum operating size. And the fourth one is ensuring the flexibility needed for adjustment in technology, product features, and the product mix and the volumes, that is the units. So basically, forecasting demand. Now here we talk about forecasting based on past numbers, side by side forecasting on a real-time basis, where the forecasting comes in. Understanding the equipment, here we talk about the specifications of a particular equipment in terms of its capacity, side by side its capability, because there are certain equipments that require maintenance, and that means some downtime for that activity to take place, and that is counted against the time to meet the customer order requirements for delivery purposes. So you have to keep that in your mind, as well as the expense incurred on repair and maintenance. And the production run is also part of this capacity, where you look at the capability of a machine to generate a specific amount of output or a number of units. So you really want to increase that capacity if you really want to meet the different customers' volume size orders, large orders, sizable orders. And then finding the optimum operating size. Here we talk about the best fit, neither more nor less, but favorable for a given situation, for a given customer requirement. And for that, how nimble, flexible, efficient you are in meeting those requirements. We talk about that. And then ensuring the flexibility needed for adjustment in technology. Now here we talk about scaling. We're improving, we're incorporating latest technology into the existing equipment, and so on. Here on the screen, as you can see, the concept talks about drum, buffer, and rope. Basically, it's an analogy when it comes to production and operations management. The process, these synchronous process are where we talk about interrelated sequence of activities taking place. We define them in terms of drum, buffer, and rope. So the theory of constraints, where we need to understand the meaning of constraints under this theory, that the system's overall efficiency is uh, limited to its weakest link. For example, if there's a big highway, but there's a narrow congestion of that highway due to a bridge. So the overall efficiency of that highway is reduced to that bridge only. So the theory of constraints utilizes the concept of drum, buffer, rope, basically to work your way around the bottleneck that is in our example is a bridge. How are you going to work around that? That is where we talk about the concept of drum, buffer, and rope to help in the implementation of bottleneck and non-bottleneck scheduling. So if you are facing a certain bottleneck along your production process, then you will turn to this theory of drum, buffer, rope to work your way around that. In brief, the drum is the beat of the system, and that beat is actually determined by the customer orders received. So you have to work to that beat, to that customer orders your organization is receiving. It provides the schedule, the pace of production, and that schedule has to meet the requirement of delivery time, date, and other details required by customers. So that is where the beat comes in. The second part of that is buffer. Buffer is a resource, usually inventory of raw material or finished goods, which may be helpful to keep the bottleneck operating at the pace of the drum. Here, the concept of order management comes in when you are running short of finished goods items because of your bottleneck or any other certain unexpected occurrence along your production line. Then you have to have some additional units available to meet the customer requirement as uh, that comes by. So there is one way of meeting, working your way around and overcoming bottlenecks by having sufficient or more than sufficient amount of inventory to meet the contingencies. However, there's another approach to it where we talk about the spare parts or the raw material that is used in the assembly of or the manufacture of that product. So where you could run out of those materials, and that would bring your production process to a grinding halt. In order to avoid that, you have to have sufficient inventory of relevant spare parts or relevant components, relevant raw material available, so that even if you run out of that, you have some extra in spare which you could utilize to keep that production belt running. So that's how you could overcome the bottleneck if there is any in your way. And finally, the rope provides the synchronization or communication necessary to pull units through the system. Workflow based on information sent, information received, and that process makes a continuum all the way from your source of origin, that is where your suppliers comes in, and all the intermediaries involved in between up until your factory, the place, the facility of production, and from there all the way down to the customers, and incorporating in between all different intermediaries along your downstream market, not only the upstream but also the downstream warehouse, retailer, distributor, and the the transporters as well, the transportation services as well, the logistics partners as well. So the rope provides the synchronization and communication necessary to pull units through the system, and that information is received from the retailers and retailers is interacting with the customer, and that information is passed along through to the factory for production and operations. And for that, a prior planning has to be done by the procurement department in close collaboration with the suppliers. So that's how the information works as a rope that ties in every link in the whole chain together to make this process run seamlessly and flexible as well as efficient and reliable and quite responsive at that. All right, so here the tactics for matching or adjusting capacity to demand. Here we talk about how to match our capacity or adjust it to customer demands. Uh, the first point here is making staffing changes, increasing or decreasing the number of employees or shifts depending on lower demand, or increasing it when the demand is higher. The second point is adjusting equipment, purchasing additional machinery or selling or leasing our existing equipment, where you decide, do you really want to make it on your own or you really want to outsource it to someone else? So here the mission critical component comes in when you see that the demand is persistent and the customer's orders are recurring. So then you might want to have a tight control on that mission critical aspect. So you want to invest more in that for the long term period of time. So where your capital expenditure comes in, not really the revenue expenditure, but rather the capex comes in, and you really want to establish that as a permanent facility based on the recurring customer orders uh, and the client base that you have. Otherwise, you might want to outsource it if it's not that much recurring. The third point is improving processes to increase throughput, that is your output, reducing setup times. At the company's name is MT Global Technology, that added the equivalent of 17 shifts of capacity by just cutting down on the installation time. That is where we come across the dynamics of efficiency led by rapid and quick installation processes, and through the use of technology, how you could merge different activities together, eliminating redundant activities and saving up that time for increasing your productivity. The fourth point is about redesigning products to facilitate more throughput, redesigning your layout as well, uh, and also maybe the products that are used to serve customer, maybe you want to change its design, or maybe you want to improve its efficiency to cut down on the time to serve, and that is your saving, and that would make you more efficient, just like Starbucks did, basically redesigning the scoop. Earlier it was used twice, now it was used once, and as a result the time to serve customer drastically reduced. The fifth point is adding process flexibility to better meet changing product preferences. Yes, now if you make to order, if you deliver to order, if you design to order, if you engineer to order, where you talk about customer driven production facility, then that is where you have to be operating in the context of being flexible. And then the sixth point is about finding out which ones are the bottlenecks that you really want to close down, which are not living up to the mark, giving the required revenue, and taking a large chunk of your fixed cost because of less demand, or maybe the market not size is not sufficient enough to justify the production there. So maybe you want to contract and close down or shutter down other facilities depending on your current market situation. So the foregoing tactics can be used to adjust demand to existing facilities. The strategic issue is, of course, how to have a facility of the correct size. That is where we talk about the optimal size that is required for this just given situation. Then there are considerations of break even in terms of units, and that's how it has been derived here. And we have uh, identified here break even in units is when the total revenue equals total cost. So total revenue equals total cost is unit price per number of units. So here uh, basically we have equated total revenue to total cost, and total revenue is unit price times number of units, and total cost is fixed plus variable cost. So we have equated these two equations into this and this equation respectively. Here px equals fixed cost plus variable cost. From there we have calculated the break-even point in units, and now we have checked it by giving the values. Fixed cost is 200, variable cost 80, and price is 120. And from there we have been able to calculate the units, that if we sell 5 units, then the total cost incurred would equal the total revenue earned, that is 120. So with that, if you multiply 120 with 5 units, we will get 600 uh, dollars. So that is the amount of revenue that we generate. So that is our break even in terms of revenue. Just to verify it, we have here derived the formula. Going with that previous formula, we have multiplied it by price on both sides, and from there we have calculated the px, which is fixed cost divided by 1 minus variable cost divided by price. And this is the rule that, where we equate price by dividing it with it. And then since that's a mathematical rule, that if you want to take this, then you have to take the common denominator, and we do that. From there we have calculated 600 to 600. So it means that when we multiplied uh, in the previous equation 120 with 5 units, the answer was 600, which is correct here. With this, we conclude this session. Thank you very much.